Consider the titration of 25 milliliter and 0.19 molar of weak acid of a weak base with 0.19 molar hydrochloric acid. The Kb is 1.7 times 10 to negative 9. We need to calculate the pH after addition of 25 milliliters of HCl. So 25 milliliters, that's the equivalence volume. So that's the equivalence volume, which means at that specific point, the titration after adding 25 milliliters of HCl, you no longer have the analyte, the weak base. All of the weak base is converted to the conjugate acid, okay? And you should be able to calculate the concentration of the conjugate acid at this moment. You can use M1V1, M2V2 to find that out. But anyway, as you can see, the initial concentration is 0.19, and now the volume is simply doubled, so therefore the concentration should be halved. So 0.095 molar, okay? That's at the equivalence point. However, this conjugate acid will undergo Ka reaction or dissociation reaction, all right? And this is a Ka expression for this dissociation reaction, okay? That should be H plus. That should be H plus. Let me see if I could do that. Okay. So now let's take a look at the concentration profile. Okay. Right at that moment, let's say before the dissociation, you have concentration 0.095, we got that from there, and then virtually you have nearly 0 for B and H plus, okay? However, if we assume X for A and H plus is formed, okay? So again, we are using the relative quantity. So here it should be the concentration, okay? So that's then for BH plus, the product right there at the equivalence volume, and that should be reduced by X, okay? So therefore, let's write Ka. Ka, again, we don't know, but we can calculate that from Kb. This is the Ka now. And then B is X, H plus is X. Then we can just write down X squared over the concentration of BH plus 0.095 minus X. Since this negative 6, pretty small number, we can just drop this X. Ka, this value equals X squared over 0.095. Then you should be able to solve for X, which is hydrogen concentration, hydrogen ion concentration. And then you take the negative log of this 7.47 times 10 to negative 4. That should be the pH, 3.13. And choice D is the correct answer. That's it for this question.